we all have the notes open?
Huh?
Notes, 8.3.
Oh. Can I show you something I did in photography today?
I'm recording right now.
Oh.
I mean, I guess. The whole world's gonna hear about it now. Tell me what happened.
I made this thing photography.
Oh, you can show me when we're done with the lesson. 8.3. Okay, 8.3 is about similar triangles. So before we were just dealing with all types of similar polygons, now we're going to be specific to just triangles. So do you guys remember in section 8.1 when we were proving that polygons were similar and we had to show all of the angles were the same and then we had to show all of the ratios were the same, and it was like a really annoying long process? Yes. Hold on. So with triangles, there's actually shortcuts. So instead of every single time showing all of the angles are the same and all of the sides have the same ratio, we could take some shortcuts with triangles to show that they're similar to each other. So the first shortcut that I could use is if you show two angles are the same, that's enough to stop right there and say that the triangles are similar to each other. Okay, so all you need, two angles have the same measure, and we would say that they're similar by angle-angle similarity. You need that little similarity symbol. Okay, so that's your first shortcut.
Well,
Yes?
on the homework, they didn't have that, like, the lines and stuff, so how would you, like, determine?
What do you mean?
So, like, how would you determine how, if they're equal or not, if they don't have a line? Because on the homework, they didn't have a line.
Then you wouldn't be able to use this shortcut. You would have to use a different one.
Okay.
So the second one would be side-side-side similarity. Okay, don't get that confused with congruent triangles. You need the similarity statement. So I'm not trying to prove that the sides are the same. I'm trying to prove that all the sides have the same ratio. Okay, so if I'm given all three side lengths in both triangles, if I find all the ratios between those and they're all the same thing, I could say, okay, these triangles are similar to each other. Okay? So that's your second shortcut. Again, you need the similarity symbol. And the third shortcut is side angle side similarity. So what I need to be able to show is that I have one pair of angles that are exactly the same, so they have the same measure. And then I have two pairs of sides that have the same exact ratio. But it matters what sides you use. Okay, so it has to be the sides that are forming your congruent angles that have the same ratio. So I would have to show that AB and DE have the same ratio as AC and DF. Yeah. There we go. Okay, so if we show that these ratios are the same, I have congruent angles, I could say that the triangles are similar by side angle side. Okay, so let's practice using these. So in example 1, it says determine whether the triangles are similar. If they are, write the similarity statement. So, okay, I'm going to write out our three shortcuts. We could either use angle-angle, side angle side, or side 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 similarity. If you look at the diagrams, they kind of guide you into what shortcut you're probably going to use to show that they're similar to each other. Well, if you're looking at it, are they giving me any side lengths?
No.
So, are you going to be able to show that the ratios are the same if they don't have side lengths? Well, if you don't have numbers, can you show that the ratios are the same?
No.
No, so I'm not going to use side, side, side because I don't have any side lengths to prove that. I'm also not going to use side angle side because I don't have any side lengths to show that the ratios are the same. What are they giving me in those two triangles? Two angles. So I'm going to try to show that I have two angles that are the same measure. Well, without doing any math, I already see right away I have one pair of congruent angles. G and D, why? Yeah, because they're both 90-degree angles. Okay, so there's one pair of angles. I just need to find one more pair. Which ones? How do you know K and C are the same?
No, that's A, that would be B.
So we know C is 26 degrees.
And H is 60.
How would we know K and C are the same? What would I have to do? Yeah. Yeah, keep going. Close. So if we want to find the missing angle of triangle, yeah, we have to add these two together first. 90 plus 64, so that gives me 154. Uh-huh.
Oh.
So they're the same. So angle C is congruent to angle K. Okay, so now that I have two pairs of angles that are exactly the same, that's enough to stop right there and say I have similar triangles. So it's much shorter than what we've been doing before. So I need to write my similarity statement. So triangle, let's just say DCE, is similar to, remember order matters. Okay, so which angle corresponds with angle D in the other triangle?
Angle G.
Angle G, because they're both the right angles. What matches angle C? And then H, and then we just have to say why we know. So by angle, angle, similarity. Yes, Taylor. Huh? So we already know that the right angles are the same, right? So we want to find another pair of angles that are the same, but we don't know this angle measure, so we have to find it first to see if it matches this angle. Okay, to find a missing angle in a triangle, you add the two angles you have, so the 90 plus 64. That gives us the 154, and then we subtract that from 180 because the triangle is 180 degrees. So 180 minus 154, that gives us 26. So they both are 26, meaning they're both congruent to each other. They're the same. Okay, so because I have two pairs that are the same, I can say the triangles are similar. Okay? Why does this keep falling? Thanks. Are you going to be okay with that? Oh, yeah.
I wonder if Ryan's going to be watching this. You can hear my voice now,
All right, example 2. So we have AA, SAS, or SSS. Okay, if we wanted to use SSS, are they giving us all three side lengths?
No.
How many side lengths are they giving us per triangle? 2. This one has 2, so I'm going to try to prove this one. I can't use this one because I don't have 3 side lengths to show that the ratios are the same, and I don't have 2 angles. Parallel. So you could technically, but we're not going to go there. Okay. So if we want to use side angle side, we need to show that the two pairs of sides that they're giving us have the same ratio. Okay, so I'm trying to compare this green triangle to the blue triangle. So SV. What side corresponds with SV?
Or SV on TV, you'll be,
Oh, SV?
It could be on TV too, right? Or not?
So SV,
VU.
between these two sides in the green triangle, SV is the smaller side, right?
Also, in order to do the...
Yeah, so in the blue triangle, the smaller side that they're giving us is UV, so smaller side corresponds with smaller side. So it's got to be SV and VU. Okay, so that's 3 over 15, and then we want to reduce that ratio.
And then you have to do RV now.
Yeah, but we want to reduce the ratio first.
15 to start.
1/5. Okay, so now we have to see if the other ratio is going to be 1/5 as well. So like Guillermo said, RV and VT. So 5 over 25. 1/5. Okay. So I have two ratios that are the same. Okay, so we're on the right track.
Are we done?
Well, all I need now is to prove I have a pair of angles that are exactly the same. I'm asking you to dig all the way back to the beginning of the year and look at this diagram and try to find two angles that are the same to each other. Angles. S what?
SMU or V.
I'll give anyone one extra credit point if they could tell me what these angles are called.
Congruent.
They are congruent, but like what's the name?
Adjacent.
Nope.
Oh, shit.
Kind of.
Um,
Gia, do you remember? You think you got it?
Linear.
No. It is vertical. Nice job. Vertical angles. Remember, vertical angles are when we have the x and it's the opposite angles in the x. Okay, so vertical angles are always congruent. So you should be looking for vertical angles in your diagram. Okay, vertical angles are always congruent. So I have my two ratios are the same. I have a pair of angles that are the same. I could say that these triangles are similar to each other. Okay, so triangle SVR is similar to triangle UVT. Why do we know?
Because they're vertical. No.
Of which shortcut?
Oh,
SAS.
SAS, because we showed two sides with the same ratio, one angle. Okay, examples?
Wait.
Did you know that if you write stuff down, you remember it better?
Yeah, no.
Okay. You're
No,
just
I
gonna
know.
write it later?
I can always go back.
Okay, example 3. Again, determine if they're similar by one of our shortcuts.
So, this longest one, so we might go 14, 21.
So you're gonna use the sides. Okay, so it's either gonna be side, 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 or side, angle, side. Which shortcut do you think is gonna work?
Similar to east.
Are they giving you 3 side lengths?
No, it's okay.
So it's gotta be side, angle, side. Yeah. So let's find the ratios.
EC, CD.
Yeah. Yes. Oh, just put it back. Just push it. Use your hand. Let it go back. There you go. Okay, then just put it on the ground. There you go. All right, AC. AC matches with what side in the green triangle?
I thought it was gonna be can you start with EC too?
Why is it CD?
That's just the longer side.
It's the longer side. 27 to 21, 27 is longer. 18 to 14, 18 is longer. Yes.
Can we start with EC too?
Yeah.
Oh, okay, that's what.
Yeah, you can start with EC and you put EC with CB. Like you would have to do EC to CB.
Yeah.
So 27 to 18, so your ratio is just going to be flipped, but that's okay. Yours is just going to be opposite of mine. What could I divide both 27 and 18 by?
Divided by 21. Oh,
What goes into both 27 and 18?
Oh,
Bigger.
what did she say?
6.
7.
No, 9.
I mean,
9. 27 divided by 9. 3. 18 divided by 9. 2. So Guillermo, your ratio should be 2 over 3.
Can I do B?
Yeah. And then we have to show BC and CE. 21 over 14. We could divide both of those by 7. 3 over 2. Check, check. I have two sides, pairs of sides that have the same ratio. Now I just need an angle. Yeah, same thing. Vertical angles. Okay, now we have similar similar triangles. So, who wants to try the similarity statement? Guillermo.
So, I wanna do this, I feel like
You can name it any way you want, the first triangle.
ACB.
Okay. Now this is where order matters.
And the other one, I want DCB.
Yep.
Just like I saw it prove.
By side angle side similarity.
I got it right?
You got it right.
So you know what I did?
What?
I don't know. So I went back to the other column
Uh-huh.
and I checked which was he picked first, and I saw that I just counted.
That's fine.
So.
You're using your notes. That's fine. That's okay. Okay, B. Louis, let's hear it.
So, P, side equals side,
Why?
because it's only two sides.
Okay, so prove it.
What you mean prove it?
Like, what? Are the ratios the same?
Oh, yeah.
Did you show it? I need to see it.
Okay, so.
So let's start with XZ. What matches with XZ?
DD.
Okay, because those are the two bigger sides. So 30 over 50.
Okay.
So that's what, 3/5?
Yeah.
Okay, then we have XY.
XY equals AD.
Uh-huh.
Which is 35.
So 21 over 35. Mm-hmm. So 3 over 5. Boom, boom. We have same angles right here because they have the same measure. So,
You gotta go in order for the first.
no, it doesn't matter what order the first one is.
Okay, so.
I would start with the angles that match. So like X.
X.
Just go in any order. X,
Oh,
Y,
X,
Z. or-
Y, Z.
Okay.
And then X, D,
D.
E, G,
Uh-huh.
and 0.
No, wait. So X to Y is crossing the smaller side. So I need to go D to J. Cross the smaller side between the two.
Oh,
So DJ, G, by side, angle side, similarity. Okay. Part C. What kind of information are they giving me?
Only sides.
They're only giving me sides. Which shortcut only uses sides?
SSS.
SSS. So we need to show all three sides have the same ratio. So FE goes with which side?
FE goes on BC.
Be careful.
Oh yeah, my bad. AB.
Yeah. Why AB, Guillermo?
Because I mean, there's
Yeah, 9 is the smallest out of these three. 3 is the smallest out of these three. So smallest sides goes with smallest sides. So this reduces to 1/3. Then I'm going to go to the middle length. So DE and BC. 4 over 12. So we get 1/3. And then our longest sides, DF to AC. 1/3. Boom, boom, boom.
wait.
And wait, we need our similarity statement. A, B, C. So this is how you figure out which one matches with A. A is between the smallest side and the longest side. So looking at this triangle, which point is between the shortest side and the long side? F. So it goes F, and I went A to B, so I crossed over the smaller side, so F to E.
T to D.
Uh-huh. Side, 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 similarity.
So it looks easy, but
But I know, when you get home, you're probably gonna be a little confused, and that's why we're gonna spend a whole nother day on this. Okay?
So I
it's like a class. I did a review. I come with First comes.
And then you forget. Okay, I'm gonna need to kind of fly through this because we only have 5 minutes and I'm recording this and I need to get both of these examples in the video. Okay, so just a side note, once you know the triangles are similar, you can use properties of similar polygons to solve for missing pieces of your triangles. So I can find missing sides and I can find missing angles. So I need to determine if they're similar, and if they are, I need to find the missing pieces. So they are giving me side lengths, except I can't use side angle side because they're not actually giving me this length. I don't know what it is, so I can't actually prove they're similar by saying the ratios are the same because I don't know this number. So instead, they're actually giving me angles, so I can prove the angles are the same. Well, I already know R and B are the same because they're both right angles.
So we do like 180 minus.
Yes, we're going to do the same thing we did before to find one of the missing angles. So like 55 plus 90, that's going to give me 145. And then I could do 180 minus 145, which gives me 35 degrees. Okay, so this angle and this angle are the same. Now I have two angles that are the same, done. I know that they're similar. So ACB is similar to the other angle that matches with A is P. And then it goes to C, so Q, R by A similarity. Because they're similar, I could actually find X now because I know the ratios have to be the same, so I could set up a proportion. So I could do X to 3 because those are the two smaller sides, and then 6 to 4. Cross multiply, divide by 4, so X equals 4.5. Then lastly, number 5. So they are giving me two angles here, but they're not giving me two angles in here, so I can't use angle. But they are giving me all of the side lengths, so I'm going to try to prove side. So I'm going to try to show all of the sides have the same ratio. So I'm going to do EC to FH, because those are both the shortest sides. You can write this down. I'm just going to flow through it. So try to listen to what I'm saying instead of writing it down, because you could always write it down later. So then I'm going to do DC to FG, because those are the middle lengths. And then DE to HG.
Please stand for the
Just stand or just sit.
In the name of the Father,
One
and of the
third.
Son, and of the Holy Spirit. Amen.
Boom.
Remember, O most gracious Virgin Mary, that never was it known that anyone who fled your protection, implored your help, or sought your intercession was less than needed.
Okay, because they're similar, I could find the measure of angle H, because we know the angles that correspond are the same measure. So I could say that this is 105 because those correspond. I could say this is 25 because those correspond. So I could do 105 plus 25
And let us remember,
equals 130,
in
180
the name of the
minus
Father,
130
Son, Holy Spirit. Happy Conception Day.
Woo! Alright, homework is due. What's today? Friday.
Let's go right there. Oh my god.